All right, here's a little bit loop algorithms. These are great for your brain, trying to figure out how to go through the loops, throw a couple if statements, use a couple variables, and do some tasks. We had 5 tasks to do, building off of our little roller project here, right? So here's our roller project. Let's go through and do the first task. So the first one there wanted to say count the number of sixes. So it said to put this into the H key. So let's go key press letter H. A little bit of code here. Basically, to count to sixes, we just want to be able to go through the list. So let's do this. Size of the list, ds list size of roles. If size is 0, there's no point even being here. So we're just going to exit out. Otherwise, let's set up a little counter and a loop. So I should actually make that a variable there. Variable count, started at 0. And here's our for loop. I'm going to start in slot 0. K is going to go less in size. K equals K plus 1. And I'm going to pull the value out of the list. So value, ds list, find the value inside of roles, slot K. And now I just want to ask if it's a 6. So if the value is a 6, then count plus equals 1. So count goes up, and that's really it. That just keeps going and going and going, and when we're all finished, I can do a little show message, string, count. Okay, and it'll tell me how many 6s there are. Okay, we can give this one a little run here. And of course, you can look at the screen itself. So when I roll, there's my thing. I hit H and 2 6s. And as I scan through, there's 1, 2. Works okay. I'll roll again. Hit H. 7 of them. 1, 2, 3, 4, 5, 6, 7. Yeah, so it looks like it's going pretty well. Okay, so that's the count the 6s code. Right? Remember, when you're in a loop, you can do as much code as you want and as complicated code as you want. It doesn't always just have to be one line, right? We're just doing nice beginner ones here. So that's a good example of the if statements inside of the for loop. Okay, let's do the next one here. We're supposed to add total, so let's add the T key in there. Add event, key press letter T, and let's sneak this one in here. So a bit of the same thing here. If I want to do a total, let's make a variable called total, set it equal to 0. I'll do the size of the list a little different this time, but basically I want to go through the whole list. So I'm going to start in slot 0, and this time I'm going to do this. K is less than ds list size roles. Okay, you can do that. There's really no difference whether you do that, before and make a variable, or just do it right here. This technically is, I guess, a bit more time consuming. Every time it comes to check the condition, it has to sort of run that script again, but it's not a big deal for our little tiny lists. But just letting you know you can do that. And now I want to pull the value out. ds list, find value, roll slot K, and I want to add that value onto my running total. So right now my total is 0, but when I go total is total plus val, it's going to add that value onto total. Then it loops back up, grabs the next value out, adds that value onto total. So total keeps getting bigger and bigger and bigger. Each time I'm just adding that particular value onto the variable. When I'm all done, I can do a little show message, string, total. Okay, let's give this a go. But that's that little loop algorithm. So we give us a roll, and now let's hit T for total. 74. I'm a little old here. I'm not going to bother adding that up, but it sounds sort of right. Let's try it again. Let's roll. Total. 80. I mean, you can add that up. I'm pretty sure it's working. But that's your total routine. Okay, so again, not too bad. Very popular routine, by the way, in coding, to total things up in a list. All right, the next one I like a lot. It's find the index position in the list of the number 1. Now here's the neat thing. Let's do this inside of key press letter F. Now, to find this 1, there's actually a method we could just use. We could just do something like this. Where equals dslist find the index position inside of roles of the value 1. And really, that's it. Now, that being said, I'm actually going to code this one in myself. I'm not going to use their built-in method. So if you thought of using that method, that's great, but we're going to code this ourselves. So here we go, finding the 1. I'm going to find the size of the list. I'm going to set up a little loop here. I'm going to start at 0, go less in size, and I'm just going to ask a simple question here after I grab this thing out. I'm going to find the value in slot K. So I've just grabbed that value out, and I'm going to ask if it's a 1. If value equals 1. Now, if the value does equal 1, I've just found my first 1. I'm going to do something very clever here. I'm going to show a message, and my message is going to be found at, and the position I want to show here is K. Remember that K is the slot that I'm currently on, right? That's the index position I'm grabbing out of. So if I print out K, that is the slot I'm on. So if it's in slot 7, K is 7, I grabbed out 7, it happened to be equal to 1, then I print out found at 7. Okay. We could add this if you don't want to be confused. Found at index 7. Now here's the thing. If there's more 1s in the list, I don't want to keep finding this 1, more 1s and printing again, found. So I do a nice little thing here. I could either go exit and just leave this event, or I could break out of the list, or break out of this loop. Right? So we're just out of here. And I'll just use the break because I think the instruction said to use break. So I'm out of the list. If it never finds a 1, nothing ever shows up. Okay, and we just end up on the cursor line. Okay, so not bad. Give it a test. So I give a roll. There's my first one there. F. Found at 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. Re-roll. F. Found at 0. Yeah. Roll. F. Found at 2. Yeah. So it looks like it's working great. So that's that one. Now, for the next two challenges, or the next two tasks here, we want to just change the values in our list. It says that I should go to my roll, and instead of 1 to 6, we're going to change it to 1 to 100. And you'll see why. We're trying to find largest and smallest values. And so, we want the numbers to be a bit more different, right? So there's variety in there. So 1 to 100, that's going to work. And now we're going to do the highest value in the list. So I'm going to do this in the L key for large, so letter L. Now this is a standard first-year computer science loop algorithm. Almost every computer science student has to do this if they take a college university course. Basically the routine is that you want to keep going through the list, always remembering what the largest value you've currently seen is. And every time you come across another value that's larger, you switch your value. Now you remember that value. And you keep going through the list doing that. And by the time you hit the end of the list, you've kept track of what the largest value you possibly saw was. So let's go through it and give it a little go here. First little check I'm going to do is my typical. I'm just going to get the size of the list. If the size is 0, I'm just going to get out of here. Otherwise, I'm going to make this variable called largest. Now, this is a little trick. Largest should be equal to the largest value that I've encountered so far. Now, I haven't really started my loop yet. So what I'm going to do is I'm just going to assume something that's pretty safe to assume for now. I'm going to assume the largest value in the list is the first value in the list. And that value is slot 0. So I grab the value out of slot 0, and now I know what that value is. Now, it may not be the largest in the list, but for now it is. Now I'm going to start my loop, and I'm going to start going through. So k equals 0. K is less than size. I'm going to go up by ones, and I'm going to pull that value out. So value, ds list, find value, inside a roll, slot k. Now I'm going to ask if the value is larger than largest, then I should set my largest variable to remember this value. So largest should equal that value you just pulled out. And that's it. Let that loop work its way to the end. By the time it's gone through the entire list, I should be able to show largest is and there you go. And it should work. Now, if you don't believe that this kind of stuff works, just make up a short list of numbers yourself, work through it, and just follow along with the code, looping every time, and you're going to see that your largest variable does always get updated as it passes larger values. So let's give this one a run. So roll, big numbers now, L. Okay, 98, it happened to be the first one. Let's give that another go. 94, happened to be the second one. 100, yeah. 99, yeah. 100 again. What are the odds here, right? 98 down here. So yeah, it appears to be working, right? So it's a very common routine. Feel proud if you got that one on your own, because you're pretty well at first year university computer science programming level with this routine. Okay, it's a popular standard. Now, along with this popular standard one goes the last of our challenging algorithms here, which is, can you tell us where the smallest value in the list is? Now, this just doesn't mean find the smallest value. It means find where it is, right? This was just keeping track of the largest value. You got to write a routine that tries to find where it is too. So I'm going to start by copying all this, and let's code this in the M key. So key press, letter M. I'm going to paste it all in there and see if it makes any sense just to change what we need to change. Okay, so here's a general idea. If the size is 0, we get out of there. That's still good. The instructions say to keep track of the smallest value, and we do something very similar. Smallest, we're going to assume the smallest value is in slot 0. And then we're going to also assume something else. The position of the smallest is 0. So I keep track of the value, and I keep track of the position that it's in. Because remember, my ultimate goal is to be able to find out what position the smallest value is in. So, for k equals 0 to size, that's all good. We're going to start, and as we go through, we pull out the value, and I'm going to ask if the value that I just pulled out is less than smallest. So I found a smaller number. I have two things that I have to update here. So I'm going to add my curly brace. Curly brace. I have to keep track that the smallest is now whatever value I just pulled out, and I also keep track of the position. My position variable should remember index position K, because that's where it was. And that's really it. And here I can say smallest at position. And what variable do I print out here? Position, right? That was keeping track of the positions. And that's your find and index position of a smallest. Let's give this a little run. I fill it up, and M. Position 18 had the smallest, and that's this one right here, and that is the 1. Pretty good. Roll. Smallest at 10. Let's see, so the value was 1. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So it looks like it's working well here. Smallest at position 5, and that's the 4. 0, 1, 2, 3, 4, 5. Perfect. Well, if you got all those routines in this video, you're amazing for a beginner. You probably have a good future in programming. Most people, when they get to largest or index of smallest, have a little trouble, but then once they see the tricks, right, and these solutions, they go, oh yeah, okay, that's not so bad, and you can start using them in your programs yourself. In the next lesson, we're going to take a look at very similar routines to this. We're going to take a look at some routines that are used in your games that use loops and lists, like fire at the closest monster for like tower defense type games. And then another one is like splash damage, damage all monsters that are within a certain distance of you. We're going to show you those two with loops. Just to show you now that you've learned the loops, you can really use them anywhere you think you need a loop. Thanks for watching.